today we are going to discuss about few problems related to amplitude modulation, what we have discussed in the last class. So the relations what we have discussed in the last class, I will jot it down one by one, and regarding to those relations we will proceed for those numericals. Okay, so we'll start. So last class we have formed a relationship between modulation index, carrier component, transmitted power, as well as the current relationship also we have identified. Okay, so two relations I will write, or I will write just like as a formula. Okay, so first formula is power relation. Power relation. So in this power relation, transmitted power is our AM signal, which is equals to carrier power plus sideband power. Okay, because in AM signal we have three different components. As we are dealing with single tone, first component is carrier and rest of the components are sideband. So this I can expand PC plus LSB plus USB. Okay, so this is the relation. Now what is PC? PC you have seen it is AC square by 2R. Now what is this R? R is the resistance offered by an antenna when it is delivering to the free space as an electromagnetic wave, what I have discussed in the previous class. So this is PC. Now PLSB or sideband power is equals to upper sideband power is equals to how much we have written? We have written in terms of modulation index, it is MS square AC square divided by how much? Divided by how much it is? Divided by 4 or 8? It is divided by 4. Because individual power, if I will add, it is called as 8 I can write, or in terms of Vm if you are writing, then you can write Vm square by 8. Then we will write for modulation index. So the sideband power is available as Vm square divided by 8R. So that when I will add these two, it will become as a Vm square divided by 4R. Now in place of Vm, I can substitute in terms of modulation index. So it is Vm by AC. Okay. Now what is Vm? It is Ma into AC square. So it is Ma square into AC square divided by 8R. Now if I want to determine total power, that means I will write AC square divided by 2R plus these are the two sideband. You have to add these two sideband. If you are adding, you will get Ma square AC square divided by 4R, which is equals to, if I will take AC square divided by 2R common, it will become 1 plus Ma square divided by 2. Then now what is this? This is nothing but our carrier power. So PT one minute. So our PT is equals to PC whole into Ma square divided by 2. So this is my general equation. So Ma can also be written in terms of PT, that is twice of PT divided by PC minus 1. And also we have seen in terms of current. So how we have represented current? transmitted power is equal to transmitted current I square into T. Similarly, carrier power is I square into R. Substitute this value here, you will get twice of IT divided by IC whole square minus 1. So this is the relation what we have covered in the last class. Now using this sort of relation we will solve few numericals. Okay, so that numericals also I will discuss with you. Around 5 to 6 numerical in this class we will discuss, and this numerical will help you to understand what are the relationships between this modulation index with respect to the power, with respect to the carrier, with respect to the sideband, and with respect to the efficiency also. And one more important thing was efficiency also we have calculated. Efficiency means it is sideband power divided by transmitted power into 100. Okay. Now what we have represented efficiency? Sideband power is how much? Sideband power, if I will add these two, we will get ms square ac square by 4r. It is ms square ac square divided by 4r whole divided by transmitted power. Now what is the transmitted power? The transmitted power is the AM signal, which is consist of carrier and sideband. So what is our carrier? Carrier is AC square by 2R plus sideband power is ms square AC square divided by 4R. If I will solve this, I will get ms square divided by 2 plus ms square. So this is the efficiency of transmission of AM. So I will write efficiency suffix AM is equal to ms square divided by 2 plus ma square. So this is the efficiency. So depend upon this sort of relation we are going to solve some numericals. Okay. So that numericals we will discuss one by one. So I am reading out one numerical and that I will write here and then we will solve. Okay. So first, an audio signal as given an audio signal. An audio signal given as 50 sine, that is 2 pi whole into 1500 t. Okay. Amplitude modulate a carrier given as 60 sine 2 pi whole into 100,000 is 1 lakh t. Okay. Now here this is the problem. Now we need to determine bit A, modulation index and percentage of modulation. So this is the first one. Okay. Bit B, modulating and carrier frequency. And bit C is what are the frequency frequency available in the AM signal. Okay, so this is my question. So depend upon this question, we are going to identify first modulation index and then second percentage of modulation. Then with B we are going to identify the carrier and modulating frequency. Done? So depend upon this, first I will write what are the given data is given. Okay, so given data is, as it was written, it is an audio signal. Audio signal means your modulating signal. So modulating signal, I will write m of t is equals to 50 sine 2 pi 1500 t. Okay. Amplitude modulate a carrier means a carrier is given. This is the carrier. So let us consider C of t is equals to 60 sine 2 pi 1 lakh t. Okay. So this is the modulating signal, this is the carrier signal, and we need to represent in modulated signal, modulation index, percentage of modulation. So bit by bit we will start. First, modulation index. So modulation index is the maximum amplitude available in modulating signal divided by the amplitude available in carrier signal. Now here there is only one modulating signal is available. That means it is called as a single tone. I can write it is called single tone signal because it is only having one frequency component in modulating signal. So single tone. So that means what is the amplitude? Amplitude of message component is 50. Then what is the amplitude of carrier? Carrier is 60. So here I will get 1 by 4 or it is 0.5. Okay. Now this indicate what? Your modulation index MA is less than 1. Yes, it is the best one. That is called as our under modulation, in which we will not face any sort of envelope distortion which may contribute noise to our amplitude modulated signal. So MA is less than 1. So first is MA. Second, percentage of modulation. Percentage of modulation is indicated by capital M, which is equals to small ma into 100. So that is 0.25 into 100. That means it is equals to 25%. So this is my percentage of modulation. Then bit B. In bit B, it asks about the modulating and carrier frequency. How we will identify? From this equation we can identify. Now this whole part you can write as omega mt, and this whole part you can write omega c. So omega m is equals to 2 pi into 1500. Then which is equals to 2 pi fm. We need this fm. So what I will do? This 2 pi get cancelled out. So my fm is equals to 1500 hertz, or I will write 1.5 kilohertz. So this is my modulating frequency. Similarly, the carrier frequency I can find out 2 pi fc is equals to 2 pi into 1 lakh, which is equals to fc is equals to 1 lakh hertz. Okay, or I can write 100 kilohertz. This I can write 100 kilohertz. Done. So this is my modulating signal frequency FM, and this is my carrier frequency, which is used for modulation purpose. So this is the two things. Now next, it asks what are the frequencies that are available in the AM signal. Now here, whenever these sort of things are asked in a particular question, indirectly they are asking about the frequency translation. That means if it is a single tone, as I have written, a single tone signal, that means your modulated signal will have three basic components. Three components. One, carrier component, and two, sideband component. So you have to identify those frequency components first. Okay? Then we can go for bandwidth. So first I will draw here the frequency translation so that my AM signal can be identified. S suffix AM of F, this is F, this is 0. Only I am considering the right hand side sequence, the right hand part of the frequency spectrum. You can consider for left hand side also, reflection part. So first is my carrier, this is FC, okay, and there are two side bands are available, okay, and we need to identify the amplitude also. So if it is a carrier, I will write it is AC by 2. If it is a sideband, I will write FC plus FM for upper sideband, and this is FC minus FM for lower sideband, LSB. Okay? So that means this is called as the higher frequency, this is called as the lower frequency. Done? Now what is the amplitude? Amplitude available here is Vm by 2, okay, or you can say it is also called as Ma into AC divided by 2. It is Ma into AC divided by 2. Now as we have identified Ma is equals to 0.25 we have found out, okay. So what is the amplitude over here? I will find out Ma into AC divided by 2. Ma is 0.25. AC amplitude is 60. Carrier amplitude is 60 divided by, so this is 30. So 0.25 into 30 will be how much? 30 divided by 4. So it is 15 by 2. So it is 7.5. So here I will write 7.5. Here also I will write 7.5. And AC by 2 means AC is 60, by 2 means it is 30. So this is my amplitude available in this particular frequency position. Now next, what we have to identify as per the question, what are the frequencies available? So what are the frequencies available? One, carrier is available, okay. Second, lower sideband is available, and third, upper sideband is available. So I need to calculate this frequency as per the requirement. So how will we calculate? Let's see. So first, carrier is available. So carrier frequency, how much it is? Carrier frequency is 100 kilohertz. So it is 100 kilohertz. Done. Then I will go for LSB. LSB is what? It is FC minus FM. FC is 100 kilohertz and FM is 1.5 kilohertz, because as it was written 1500 hertz means it is 1.5 kilohertz. Now if you subtract this 100 from this 1.5, you will get how much? How much you will get? You will get 98.5 kilohertz. So this is my LSB. That is called FC minus FM. Then another component is USB, which is equals to FC plus FM. Okay, FC plus FM means 100 kilohertz plus 1.5 kilohertz, which is equals to how much? 101.5 kilohertz. So this is the upper segment frequency also we have got. So these are the three different frequency which is available in our modulated signal, and that too the bandwidth of transmission. If here I have not asked, if in question it is asked what is the bandwidth of transmission or what is the bandwidth of modulated signal, then it is twice into FM. So twice into FM means FM is 1.5 kilohertz. So it is 1.5 kilohertz. That is equals to 3 kilohertz of bandwidth. So this is the bandwidth, 3 kilohertz. The same thing you can prove here also. How we can prove? By taking the bandwidth from this particular distance to this particular distance. LSB to USB. So if I will take a difference between LSB and USB, it will become as an bandwidth. Here we have FH. How much? 101.5 kilohertz. Okay. FL we have 98.5 kilohertz. Now if you take the difference 101.5 kilohertz to 98.5 kilohertz, you will get 3 kilohertz of bandwidth. So it is same as this one. So you can prove like this also. So this is the small question, simple representation. According to the question, we have asked each and every one and each and every point with respect to the frequency, with respect to the modulation index, with respect to the percentage of modulation, with respect to the frequency available in modulating signal and carrier, and as well as the frequency component available in the modulated signal. So these are the subtle things which help us to understand that in an AM signal how many number of components are available, if it is single tone and if it is a multi-tone. Okay, so this is the first problem which we have solved. Now next we will solve for one more question in which certain power calculation is available. So that question also I will write and then we will solve it. These are the small questions which will help you to understand the theoretical concept with this numerical values. Okay. So one more question. So here the question is, how many AM broadcast station how many broadcast stations can be accommodated in 100 kilohertz if the highest frequency modulating carrier is 5 kilohertz. Okay. So this is the problem statement. Then here we need to identify the number of broadcast stations, AM broadcast station, and here hint is given that AM broadcast station is operating in 100 kilohertz. That means this is the total bandwidth is provided, and in which in that bandwidth the highest modulating frequency is available as 5 kHz, as it was written in the highest frequency modulating a carrier. Means it is not a carrier he is saying, it is a modulating signal whose frequency is 5 kHz is given. Okay, this carrier is only identifying that modulation is taken place. But here he is asking about the modulating signal. Among the modulating signal, the maximum highest frequency is 5 kHz, and this is the total bandwidth. So, how many number of broadcast system we are going to identify? Let's see. So, here I will write solution. This indicates that, for example, this is the total bandwidth, okay, which is 100 kilohertz. This 100 kilohertz bandwidth is available to you, okay. In this, the higher frequency component, n number of modulating signals are available or modulated signals are available, in which the maximum frequency, that means here I will say the F max, F max is 5 kilohertz. This is the F max, this is the frequency having certain amplitude, and this is the bandwidth of 100 kilohertz. This is the bandwidth, and the modulating signal is maximum frequency is this. Means among the modulating signal, the highest frequency is this 5 kilohertz. So when I modulated it, then it will transmitted in this 100 kilohertz. Okay, and how many number of broadcast stations is asking. So how many number of broadcast stations means the number of broadcast station is equals to the total bandwidth available by the bandwidth of a modulated signal. So this is the ratio. Now, how to calculate this bandwidth of a modulated signal? This modulated signal is one component I am saying. Okay, this modulated signal is only one, because only one frequency component is given, means the bandwidth you can identify for that modulating signal. So what I will write, total bandwidth is available is 100 kilohertz, 100 into 10 to the power 3 hertz, and the bandwidth available in the modulating signal. So this is the maximum frequency available in the modulating signal. So for this modulating signal, what is the bandwidth? The bandwidth is twice of F max. Done. So it is 100 into 10 to the power 3 divided by 2. What is the F max? It is 5 kilohertz. 10 to the power 3. This get cancelled out. Resultant is 10. So number of broadcast station is 10. So this is my answer. So 10 is the number of broadcast stations. How we have identified this 10? By simply dividing the total bandwidth divided by the one bandwidth available for the modulated signal corresponding to this modulating frequency 5 kilohertz. Okay, so this is the small numerical to understand if a particular band is given, and with the help of that particular band, if a modulating signal is available, how many number of broadcast system can be identified. So this is the small example. Okay, now we will go for one more question. One minute. So one more question we'll discuss. So here the question is total power